Section 1.6, Other Types of Equations. We're going to learn about three different types in 1.6, polynomial equations, radical equations, and absolute value equations. It's very important that you pay attention to what kind of equation you're trying to solve. For factoring, you're going to see, like, for example, x to the fourth, x to the third, x to the second, and that means most likely they're polynomial equations. With radical equations, you could see a square root, you could see a cubed root, you could see a fourth root. And with absolute value equations, you will see those wonderful absolute value signs. So how do we solve polynomial equations? We solve by factoring. How do we solve radical equations? Well, the first thing you want to do is isolate. Make sure you know that the first thing you do is isolate the radical. And then if two radicals exist, get them on opposite sides of the equal sign. Then you'll raise both sides to a power that equals the index. Why would you do that? Because then the power and the index will cancel each other out. Then you're going to solve the resulting equation, but now you've changed a radical equation into possibly a linear or quadratic equation. So you need to make sure you check your answers to see if there's any extraneous solutions. Extraneous solutions are solutions that work with linear and quadratic, but not with radicals. And then with absolute value equations, if the absolute value of x equaled a, where x is a variable or an expression, and a is greater than or equal to 0. This number right here has to be greater than or equal to 0, meaning 0 or positive. Why? Because absolute value is representing a distance, and the distance can't be negative. So if you have the absolute value of x equaling a, where a is greater than or equal to 0, then you have two answers, either x equals a or x equals negative a. And lastly, to solve absolute value equations, again, the first thing you want to do is isolate. And then you're going to write two equations. Make sure you highlight that, because a lot of students only give me one answer. You need two answers, and so you need two equations. The first equation is just by dropping off the absolute value and solving. There's your first one. And your second equation is by dropping off the absolute value but placing a negative on the right-hand side. And then you'll solve both of those equations. Again, you probably want to check your answers to make sure they're checking out and not getting extraneous solutions. So let's go ahead and try number one. The first thing you want to look at is it polynomial, radical, or absolute? Well, we have x to the fourth and x to the second, so we know it's going to be polynomial. And how do we solve polynomials in 1.6? We're going to solve by factoring. So looking at this, it's two terms, so we need to factor out the GCF. And what's in common is a 5x squared. So you're left with x squared minus 4 equaling 0. Then we're going to set each one equal to 0, and we're going to get 5x squared equals 0, or x squared minus 4 would equal 0. Before you take the square root, you need to divide by 5. So x squared would equal 0, so x would equal plus or minus 0 because we would take the square root of both sides. Now normally when we take the square root, we put plus or minus. But because 0 doesn't have a sign, we do not need the plus or minus. In the other example, we're going to add over the 4, so x squared would equal 4. Square to the left, square to the right, not forgetting plus or minus, so we get plus or minus 2. So we end up with 0 and plus or minus 2. And because it's a polynomial equation, those answers should check, and I'll let you check on your own. Number 2, we have 4x cubed minus 12x squared equals 9x minus 27. Again, this is polynomial. With polynomial equations, you want to make them equal to 0. So we're going to subtract over the 9x and add over the 27. So we get 4x cubed minus 12x squared minus 9x 0. So now we want to factor by grouping because we have 4 terms. So we'll group the first two, and then we'll group the second two. And we'll take out the GCF from each group. What's in common with the first two terms is a 4x squared, and you're left with x minus 3. Make sure you put this sign in between. And what's in common between a 9x and a 27 is the 9, and you're left with x minus 3. Why minus? Because a negative times a negative is a positive, and you pulled out the negative. So you definitely need to change your sign on that last term as well. So back in 116, we said if these are not the same, you've done something wrong. Right now, they need to be the same, but later on in college algebra, we're going to learn that if they're not the same, we can find another way to solve. So we're going to factor out the x minus 3 because that's what's in common, and we're left with 4x squared minus 9 equals 0. Then we're going to set each term equal to 0, so either x minus 3 should equal 0, or 4x squared minus 9 would equal 0. So we'll add over the 3, so x would equal 3. We're going to add over the 9 and divide by 4, so we get x squared equals 9 over 4. Again, we need to take the square root of both sides to get rid of our square, so the square root of both sides. We're going to get x equaling plus or minus the square root of 9 over 4. And the square root of 9 is 3, and the square root of 4 is 2. So we end up with 3, and x equaling plus or minus 3 over 2. Number 3. We have 3x to the 4th equals 81x squared. Again, it's polynomial. How do I know that it's polynomial? Because I have powers of 4 and 2 and so forth. So now what we need to do is go ahead and subtract over the 81. So 3x to the 4th minus 81x squared equals 0. And we're going to factor out what's in common, which is your 3x squared, and we have x squared minus 27 equals 0. Then we're going to set each term equal to 0, so 3x squared would equal 0, or x squared minus 27 would equal 0. Just like the previous problem, this gives me x equaling 0. On this one, we're going to add over the 27, so we get x squared equaling 27. So when I take the square root of the left and the square root of the right, not forgetting plus or minus, I get x equaling plus or minus the square root of 27. Well, we need to simplify that. 27 is 3 times 9, and 9 is 3 times 3. So we see that we have a pair of 3's. We know the square root of 9 is 3, so 3 is going to come out, and this 3 gets left underneath. So x is going to equal plus or minus 3 square root of 3. Again, pairs get taken out, and what's not paired up stays underneath. So those are your polynomial ones. Now number 4, we can see that we have a square root. So that means that is a radical equation. So looking back at the previous steps on radicals, the first thing we want to do is isolate. It's already by itself. So the next thing we want to do is raise both sides to a power that equals the index. So 3x plus 1 is going to equal 4 squared, which is 16. The square and the square root just cancel each other out, and we're left with underneath the radical. So we need to subtract over the 1. So 3x equals 15. Divide by 3. So x would equal 5. Now, these are the problems we have to check our answers. So let's do so. Go back to the original. 3 times 5 is 15. 15 plus 1 is 16. And the square root of 16 is 4. So it does check. Number 5, the square root of a plus 10 equals a minus 2. So what do we need to do? Isolate. Well, it's already by itself. Then what? Take both sides to a power that equals the index. And the index is a 2, so we square both sides. Why is it a 2? Because it's what number is inside this little v. And when it's not there, that's a power. That's an index of 2, so we need to raise it to the second power. So on the left-hand side, the square and the square root just cancel. And how do we do a minus 2 squared? Quantity squared. That means we have to multiply a minus 2 times a minus 2. We can't just square pieces. So now when we multiply this out, we end up with a times a, which is a squared, minus 2a, minus 2a, plus 4. Because my a squared is positive on the right-hand side, I'm going to take everything over to that side. I'm going to subtract the a, put those like terms together, subtract the 10, and put those like terms together. So we end up with 0 equaling a squared minus 5a minus 6. If you don't like the 0 on the left-hand side, just flip it over to the right because we know it's commutative. So now we need to know what are the factors of negative 6 add up to negative 5. A lot of students want to use 3 and 2, but you can't because you need a negative 6 and a negative 5. Which means one of our 3 or 2 would have been negative. I would not get a negative 5 when I added. So we should use negative 6 and 1. So a minus 6 and a plus 1 equals 0. So I end up with a equaling 6, or a would equal negative 1. So now we got to check. Again, these are square roots, so make sure you check your answers. Plugging in the 6, 6 plus 10 is 16, and the square root of 16 is 4. So we get a 4 on this side. Plug a 6 here. 6 minus 2 is 4, so it checks out. So now let's go ahead and check a equaling -1. -1 plus 10 is 9, and the square root of 9 is 3. -1 minus 2 is -3. So it did not check, so that answer gets thrown out. Don't always throw out negatives just because they're negative. Sometimes they do work. And sometimes positives don't work. So just make sure you're checking your answers. So same thing on number 6. We have t plus 7 equaling the square root of 2t plus 13. We're going to square both sides, square the left, and square the right. So just from the previous problem, we know that this is going to turn out to be t squared plus 14t plus 49. Go ahead and FOIL that out yourself, and we get 2t plus 13. So we're going to subtract over the 2t and subtract over the 13. So t squared plus 12t plus 36 equals 0. So the factors of 36 add up to 12 would be 6 and 6. So t plus 6 and t plus 6. So we only get one answer here. We get t equaling -6. It appeared twice, and we're going to learn more about that in college algebra material, which is starting in chapter 2. So number 7, we see that this is now absolute. So we saw that 4 was radical, 5 was radical, and 6 was radical. And now we're getting into the absolute value ones. So this is absolute, this is an absolute value equation, and this is an absolute value equation. So what are the directions on absolute value? First thing you want to do is isolate. So do we have anything on the same side with the absolute value? Yes, we have the 2. So we need to subtract 2 on both sides. So we get the absolute value of 2x minus 6 equals 8. Then it says break it up into 2 equations. So I want to see 2 equations written next. The first one is when you just drop the absolute value. Don't change what's on the inside, just drop the absolute value. The second equation is drop the absolute value, but we put a negative on the right hand side because you should have the same answer, positive 8 and negative 8. But again, the left hand side doesn't change. Don't mess anything up underneath the absolute value. So then we're going to add over the 6. So 2x equals 14, and x is going to equal 7. Then we're going to add over the 6. We get 2x equaling -2, so x is going to equal -1. So let's check these answers. When I plug in a 7, 2 times 7 is 14, 14 minus 6 is 8, absolute value of 8 is 8, and 8 plus 2 is 10. Plug in the -1. 2 times -1 is -2, minus 6 is -8, absolute value of -8 is positive 8, and 8 plus 2 is 10, so they both check. With absolute value equations, they either both should check or they both won't check. That's something you might want to write down. So on number 8, we have 3 absolute value of 2x minus 1 equals 21. First thing to do is isolate, and we do need to divide by 3 to isolate. So that's going to give me 7. Then we're going to break it up into 2 equations. So 2x minus 1 would equal 7, or 2x minus 1 would equal -7. Again, what's inside the absolute value does not change. Add over the 1, so 2x equals 8. Divide by 2, so x would equal 4. I'll let you check, and they both do check. So try that on your own. On number 9, we have the absolute value of x plus 1 plus 6 equals 2. So start off by isolating. Subtract the 6. So absolute value of x plus 1 equals -4. Have you noticed on all of these we've had to isolate first? So that might be a hint on what you might see on the test. Now we're going to break it up into 2 equations. We have x plus 1 equals -4. X and negative make a positive, so positive 4. Then we'll solve. So by subtracting the 1, we get x equaling -5. Subtract the 1, and we get x equaling 3. And now we need to check our answers. So let's plug in the 3. Let's show the check stage this time. We get the absolute value. Let's check 3. 3 plus 1 plus 6 is supposed to equal 2. Well, 3 plus 1 is 4, and the absolute value is 4, and 4 plus 6 does not equal 2. So that one gets thrown out. Check the negative 5. So I get negative 5 plus 1 plus 6 is supposed to equal 2. Negative 5 plus 1 is negative 4, but the absolute value makes it positive 4. And 4 plus 6 does not equal 2. So my answer is no real solution. Now, there is a way to know if you're not going to have a solution. And it's back at this step right here, because the absolute value equaled a negative. And what did we see on the previous page was that the absolute value had to be equal to an a, where a had to be greater than or equal to 0. And my a right here is negative 4, which can't happen. So you could have stopped at this point and said no solution.